In this video, we're going to talk a little bit about assembly and creating your own shellcode. I wanted to start with 32-bit Linux assembly. So this is essentially a hello world program. It starts out with a globally declared start label so that the operating system knows where to start running the program. And normally, our program code is stored in a section called text. So here's that label, start. And then we're going to make a system call. Now, remember that in Linux, if you're trying to call an operating system function, this is normally done with a system call. So here I want system call number 4, which is right. So I move the value of 4 into my EAX register. Then I move the value of 1 into my EBX register. And 1 is the file handle for standard out. If you wanted standard error instead, it would be file handle 2. And if you wanted something else, you would have to open the file. I then move my message into ECX. I move the length of my message into EDX. And then I invoke the system call by doing an interrupt hex 80. Then I cleanly exit by calling the exit system call, which is number 1. So I have to load 1 into EAX, and my exit code will be 0. And instead of loading 0 in to EBX, I just XOR EBX with itself. And whenever you take anything and you XOR it with itself, it will be 0. And then I once again do an interrupt hex 80, and that should exit. So getting back to the message, I see a label that says message, and then DB means define bytes. I define hello reverser, and then I add 10 to the end because 10 is the new line character. That way it looks nice and pretty when I print it out. And then here I do a little trick. I calculate the length using this equation. $sign means my current position, and I subtract from my current position message. So message is here. And if I subtract the start of my string from my current location, that is in fact the length. So I can go from here to an actual program pretty easily. In order to go from here to an actual program, I just need to use NASM, and I need to tell NASM that I will be making an ELF32 file format. And I want to take my input, simple32 ASM, and my output will be simple32.o, my object file. And that compiled successfully. Now I'll use the linker, LD, and I will tell it that I would like an ELF I386 simple32.o, and my output will be simple32. And that works. So if I run it, it does what I expect. I can look at a similar program in 64-bit Linux. The system calls actually changed. Notice that it's 60 for an exit and 1 for a write. And instead of using EAX, I use RAX. Again, that's the 64-bit wide register. The same thing is true with RDI, RSI, etc. And instead of doing an int 80, I just call syscall. So that's something that's new in the 64-bit processors. Everything else is the same. So again, if I wanted to compile this into a program, this one's even easier. I just use NASM, and my format is ELF64, simple ASM. My output is simple.o, and I can link it as simple.o with an output of simple. If I run simple, it says hello reverser, as we would expect. All right, so I have these programs. Now, if I want to take the executable, the assembly instructions that have been converted to machine code, and send that to use as a shell code, there's a couple of things I have to keep in mind. Now, I have a simple script that will allow me to create a string that could be used as a shellcode string. And if we look at this script, it's very simple. So this script, I got this from a great website called commandlinefoo.com. Go ahead and open it It has shebang, bin bash, and then it has this weird looking bit. Here, there's a loop. It says for I in, and then it calls the command, and it calls this command called obj dump, and then it pipes the results to a translate command, and then pipes that to another translate command, and then it pipes that to a extended grep command. Then there's an echo for what is left after all of that. And what you will get if you run this, I'll go ahead and run it on my simple, my 64-bit, I get this big long string. So I can take this and copy it and paste it into a shell script. Now, there are some problems with this, but we're going to take a brief break. And when we come back, we will discuss some of those problems and how to fix them.